All right, good afternoon. Thank you everybody for sticking around. It's a long day. I know I'm tired. My name is Adam Lavely. I'm going to be joined up here by Pengfei here about halfway through. We're going to be talking about some work that we are doing with many other people at NERSC on our containers first environment. So I'm going to throw this up and just allow you to look at this for a few seconds. And quick show of hands, how many people have heard complaints like this in the past? Actually, that's far fewer hands than I thought. Okay, there we go, yeah. Wonderful, yeah. So there are so many different people that have so many different needs and requirements and wants, and it gets very difficult for any HPC center. So let's be a little bit more complete with how we talk about this. So first of all, we know that scientific workflows are becoming far more complex, right? More complexity means that more users are using our systems in new and different ways, and that is wonderful for science. That is a pain if you're trying to run the system. So I wrote and ran simulation code for my degrees, and I really enjoyed that, but that sort of research isn't all of what's happening right now. Right? So the ways that people are connecting outside data sources coming in, either through streaming experiments or other ways, or also like HPC AI loops, however you want to do those loops. These are all different ways of using the system. And it's not really just about keeping your code up to date with the latest and greatest release, but it's also about matching all those libraries to the different drivers to whatever dependencies that you need. Second, the way that people use the system is different. I was an SSH user, I'm still an SSH user, but we have a lot of people that are getting on in interactive ways using Jupyter. We have a lot of people that are using our API and never actually log onto the system. And that is great for enabling science, but again, difficult for managing things. Third, there's definitely a lot of trade-offs between what users need, what the system admins need, well, even between what different users need. So we're always trying to find what that balance is when we're putting together the overall system. And then finally, the people that run the system, they have a hard job, even without all the different users giving them all the different things that they need to do. So let's try to make it a little bit easier for everybody. And so we've kind of put together this idea of a containers first environment, and the entire talk here today is going to be about how we're doing this. So first we'll talk a little bit and just make sure that we're all on the same page with what some of the needs are. Then second, we'll talk about our design principles. We really took a step back and said we're not going to look at individual tools. We want to look at the whole idea and rethink the whole thing. And then we'll dive into our technical approach. I'm going to talk a little bit about more the sysadmin side, and then Pengfei is going to come up and talk a little bit more about the user side of things. Okay, so I have this awesome AI-created graphic here, kind of showing on the left what our current system Perlmutter looks like. Right? This is a HPE Cray machine, and we are given a lot of things and told from the vendor this is exactly how things will be, and if you try to change anything, bad things happen. So this is awesome because it works right away, hopefully, sort of, not really, but that's what it's supposed to do. But then when we try to actually do anything new and different to it or make modifications, everything breaks. Right? This is a giant monolith that you can't really get into. Our next system, Doudna, we're actively working on this right now, putting together the software for it. We're trying to do everything in a much more modular way so that people can swap things in and out, both on the sysadmin side as well as on the user side. So as I said before, we often talk about yesterday's system being very monolithic, right? So I have some bullet points here that just kind of show some of the difficulties that we have in dealing with things, right? We have these rules or the laws given to us by the vendor. With this thing, because everything is so coupled together, if there is a change upstream, it's hard to get that in anytime soon. And if your code depends on a lot of other things, it might be 1 or 2 releases down the road before anything actually comes through. This lag is very difficult to deal with. And then also the deployment method, it was handed to us. And so we'd like to really separate that out. And it didn't come through super well on the screen. I was trying to do a rainbow with the word multiple there to show that we want to make sure that all the different users can have exactly the flavor that they'd like to have, in addition to that being separate from the system software itself. So when we took a holistic step back and we said, we want to look at this problem from the top down and not just look at, well, it'd be nice to change this tool or change that tool. The three things that we took into account were the user experience, the technical longevity, and then trying to get modern DevOps into both the system software side as well as the user software side. So on the user experience, this is something that we are experimenting a lot with, right? As the way that people use HPC changes, we want to make sure that users have the option to get something that works well for them. For the technical longevity, we're really here talking about making sure that this is something that's adaptable enough that if we develop it for our next system, we can also hopefully use that for the next system, as well as push that out to other people if they'd like to use something similar. And then the other thing that we're talking about a little bit here is just using some of the modern tools. This is something that is very important to NERSC as a whole, and especially our sysadmin team. So here I just have kind of I don't know what I'd call this, some sort of random figure that I put together. I did not use AI on this one, showing kind of the way that we're doing this. And what we've proposed is having a containerized runtime be really the place where the sysadmins and the users actually interact. So the sysadmins, I don't want to belittle their job at all, but their role here, their responsibility to the users, is to get this containerized runtime up and working well. They don't have to worry about any of the user software or anything like that. The users themselves then will build their own containers or use containers that we provide, and they don't have to worry about underlying system changes because they have control over the software that they're actually going to be using in their container. So hopefully, the two different groups can work together in this way and not step on each other's toes anymore. So we like to call the sysadmins what they're doing. We like to ask them to be nice. I did not come up with this acronym, but the NERSC Integrated Container Ecosystem, or NICE, is what we're now pushing. So we've broken this into a couple of different things here on the left, but really the idea is that we want the sysadmins to be able to provide this containerized runtime environment so that users can hop on and have the same environment, whether they are using an interactive system, whether they're SSHing on, or whether they're running jobs. So we break this into a couple of different places. So the first is the way that you actually log in. And I'll talk a little bit more about this in a couple of slides, but we're doing this with the PAM module. And then we're also having Jupyter Hub be available. That's something that you can easily swap into. I'll talk about our integration with Slurm in a little bit, because this was actually a hoop that we had to jump through to get, or that we're still in the process of jumping through. We're currently using Podman HPC under the hood for this. And then we have a series of APIs that connect to Iris, which is our user system management. So currently, when you log in, you can choose what shell you're using. In the future, you'll be able to choose what container you're using. And then finally, the way that we put together these containers is using a whole bunch of tools that we've been talking about for this entire conference and will continue to. So the way that we provision these sessions out is slightly different, whether you are using an SSH, like on the terminal with the command line, or whether you're using a web browser for Jupyter. So with Jupyter, we've actually found that the Zero to Jupyter Hub works very well for this. We're able to utilize this very quickly. But for the shell, this is something that we had to work on for quite a while. So I'll go into the different things that we looked at, and then what we chose, and a little bit of the technical implementation of that. So we had a couple of different models that we looked at. K8s was kind of the thing that everybody wanted us to do right away. But we really found that this was very difficult to get working with Slurm, to get working with the rest of the jobs. And then it was hard to also get this to work with the converged platforms that we're now using. Another idea that we tried was the jump host, and really having as few things on the bare metal as possible. Unfortunately, this was rather difficult just because there's so many additional hoops that the sysadmins have to go through to make sure that this works, that we ended up throwing this out. What we finally decided on using was a PAM module, and really this is an extension of things that we're already doing, And so the new things that our security team had to bless was relatively small. We do have to write a little bit of custom code, but compared to the others, it was actually a relatively small amount. So the PAM modules, so PAM, at least here, stands for Pluggable Authentication Modules. And so these are just little libraries that you can write, and then you put the library in a certain location, and then in the SSD file, you say, do this. So for every user, you can have slightly different rules. It's actually very flexible. We're already using this for how people log into Perlmutter today when you SSH on. But the way that we're setting this up is that we have this PAM container.so, and in there we're starting a container session. And again, we're using Podman here. And then once the container is up and running, then we're jumping into that using the same namespace. And so you log on, and it's as if you're just in a regular terminal with an interactive, any sort of interactive container. Really, this is supposed to look like when you SSH onto Perlmutter here now, so there shouldn't be too much of a difference. So I do want to talk a little bit about our container runtime choice. NERSC is a shifter in Podman HPC shop. I think we've been running shifter for 13 or 14 years, and Podman HPC for not quite that long, but pretty close. But actually, our first proof of concept was done with Aptainer. So one of the things that I want to point out is that everything that we're doing, because the user is just using that container runtime, should be invisible to the user. They shouldn't have any idea that they're in a container unless they're actually actively switching it, or what container runtime you're using. And so for us, we'd like to have multiple container runtimes available. And part of this is risk mitigation, right? If there's CVEs that we have to turn something off, we'd like to have other options so that we don't have to just turn the system off. But then part of this is also, these are all under active development. And so if there is something that gets us better performance or new capabilities, we'd love to be able to take advantage of that quickly and offer that to our users. All right, so one of the things that we are still actively working on is the scheduler integration. We really want to make sure that this is as seamless as possible. So if I submit a job from a certain environment, I want the job that I submit to be the same environment that I'm currently in. So with containers, that's a little bit more difficult because we have to get Slurm to play nicely with it. But all in all, it's really not too bad. The alternative is that if you're in one container but you'd like to be running your job in a different container, you can specify that. So there had been a bunch of plugins. This is actually something we were pretty nervous about, but it turned out that Slurm actually did this for us, and it's great when your problems are solved by other people. The other thing that I want to talk about before Pengfei jumps up is just the one issue that we're still kind of working through is how we do this integration with Slurm. So when you're in your container, if you didn't build it with Slurm, right, if you brought your own container from elsewhere, we have to inject Slurm in. And it turns out that Slurm is built in a way that is kind of a pain in the butt. So it's hard to get all the files in. We'd really like to create some sort of API so that it's quick and easy, but we're not quite there yet. That's really the thing that's holding our proof of concept back right now, but we're actively working on this and hope to have this out for internal use here by the end of the month, and then hopefully externally by the end of the year.
Thanks, Adam. Okay, so let's move on to the other side of the story. How do we provide a good user experience? Before that, let's think about all the different use cases. So we have the broad all user base that we need to provide something functioning as a ground, and then there will be power users that they require advanced capabilities that they can customize and do many other things. And there's always special cases that in those cases they may need they may need to customize the full stack. How do we handle all these cases? Well, we leverage quite a few things that DOE has already invested into the software ecosystem. OCI compliant Containerfile, Spack environment. We have a robust reframe test suite written for all of these pre-defined NERSC container recipes. And on top of, inside of that, there are essential components such as media software and tools, open source MPI, compilers, libraries, and tools. So this is a diagram showing where how we are handling all those use cases and where in those different use cases where things got plugged in. I'll elaborate more in the following slides, but you can look at the first, the top of the diagram. That's what NERSC provides to meet the broad user use case. There's a container file inside it. We have a predefined Spack YAML defining the basic programming environment, and then add a bunch of like maybe NERSC specific tools onto it, such as the tools interacting with the storage system, show the quota, etc. And then for the power users, they may plug into the step where they, after the Spack environment, they add a bunch of extra things, or a power user will just go back to one layer deeper and only inherit the base image. So this is an example of our container file. The top two lines are just the basic image and a bunch of basic OS packages. That's where the power user may just inherit. And then we have a predefined NERSC environment where it brings in MPI and other and IO libraries and other scientific libraries as well. And then the last one is the user specific additions. In this case, it's the user wants to have a Jupyter Lab installed there. So yeah, inside the NERSC provided Spack environment, where this is where we put in the default, the core HPC packages covering the compilers, communication, IO, mass libraries, and does the environment management, and also include the build tools there. This whole environment, this whole container file setup, that's robustly tested. So we have a full pipeline from the source control, and all the updates go through issues, merge requests, go through CI/CD, got pushed to our container registry, and went through the testing pipeline and made available to the users. And users can, through the configuration system such as Iris, can specify which which login container they want to use, and they can just SSH into Doudna.nersc.gov and landing the container they specify without going through the extra hoops like logging to the bare metal machine and then start the interactive container. I should stop on here, but I know this will likely get asked. So what about MPI? You have all the options above. You can just take the NERSC image, which already have all the stack available in it. But if you want more customization, if you want to have your own MPI library, you can do it. If you look at the diagram on the right, inside the container stack, the NERSC provided container image. What it has is basically the container runtime provides the device access, and inside the image, it has the OFI provide the whole stack from OFI provider to libfabric to MPI library, up to the user application. this can be modified or customized at either layer. Fundamentally, you only need that device access to the host. You can inherit from different points here, or you can pull in the library from the host and start from there. Yeah, I think that's all our story here. Any questions?
Okay, so I think we have we've got time for probably 1 or 2 questions. If anyone has questions, raise your hand. I'll come run the microphone to you.
Yeah, thank you for the presentation. I was just wondering, when you did your testing with the containers, did you see or notice any kind of overhead caused by the fact you're using containers as opposed to bare metal, especially when you scale to like hundreds of nodes?
Yeah, good question. Okay.
When things are set up right, very little. When things are set up poorly, a lot. Yeah, but we do spend quite a bit of time testing bare metal and containers to try to make sure that we're doing well with that. So there's a couple of canopy papers that others in our group have put out showing that on Perlmutter when Perlmutter first came online, and I anticipate that we'll be doing that same thing for Doudna as well.
Yeah, again, I add a few things, especially with container. You need to be careful with the I/O, especially for the image itself. That's most of the time that's the bottleneck, and that's Perlmutter HPC. One main feature of Perlmutter HPC is like making sure the image, the pull down image, is on the shared files, parallel file system, and not be a bottleneck. That's the case, especially for the HPC clusters, which doesn't have local disk or local cache.
For your build system where you have the Spack.yaml, and can you go back to your Docker file, I guess, or the slide before it, I guess, the one right, yeah. Here. Are you guys doing any build caching for the Spack builds in this? Yeah, because we have this OCI build cache format now where you could layer all the packages in the Spack.yaml and probably share a lot of stuff. But
Right. Yeah. I'm not in the programming environment group, but I'm always the person pushing for the new features. I always ask, can you set up a build cache for me?
Yeah. Okay. Yeah. If you guys are interested in that, I mean, we could talk about it at the Spack user meeting. Yeah. That's awesome.
So you're talking about the image from Podman HPC. Is it like a SquashFS format?
Yeah.
Okay. So that way it gets mounted on the node instead of all the individual file accesses on the shared file server.
Okay, and with that, unfortunately, I think we're out of time. But well, that's true. We're supposed to keep a 5-minute break. But I mean, if you want to answer it, we might just risk getting kicked out or something. But Fernando, did you?
Do you know how much storage is being now used for how long you've been running this strategy?
How much storage for the image?
For the images, yeah.
That's a good question. So, yeah, we haven't looked, but we have like per user have a special directory on our Lustre system, but we never aggregated that. We can probably do the stats for Shifter, because Shifter has a centralized path where we store all of the squashed images. Yeah. Thanks.
Okay, let's thank our speakers.
Thank you.